As you already know, the gravitational field strength G is directly proportional to the distance from the centre of the mass creating the field. In our example, the field generator was the planet Earth, and our graph shows what happens to the field as we moved away from the surface of the Earth. But if we move the other way, i.e. towards the centre of the Earth, what happens to the field strength? Well, the gravitational field strength depends upon G equals negative big G m over r squared. Big G is a constant and we are reducing r, but we are also effectively cutting away sections of the Earth. So we are reducing the mass m of the Earth. So the radial gravitational field from the Earth as we go inside reduces linearly to zero the closer we go to the centre of the Earth. And the graph will look like this. If we now consider the electric field strength from our previous example, the graph shows us that E is directly proportional to 1 over r squared again. Again, what happens if we move in the opposite direction towards the centre of the sphere? If the sphere is positively charged on the outside edge, then it must be negatively charged on the inner side. These negative charges are equal to each other, so all points inside the sphere are both repelling and repelled by all other points. This means that there is effectively no charge inside a hollow charged sphere, no matter what the charge is on the outside. So the electric field strength will be reduced directly to zero as soon as we go inside the sphere. This means the graph will look like this. This phenomena is used in a Faraday cage and can be used to explain why you are safe to sit inside a car during a lightning storm, as long as you don't touch the metal surface of the car. During this session, you have learned how to calculate the field strength in both gravitational and electric fields using both the formula shown. You have demonstrated that you are comfortable using these formula and have understood the sign convention, especially the negative sign when calculating gravitational field strength. You can also show the difference between a graph showing a relationship of 1 over r and 1 over r squared, and you should be comfortable with sketching both these graphs in the exam. Be careful and understand which relationship is which. Potential is proportional to 1 over r and field strength is proportional to 1 over r squared. You should now also understand what happens to the field strength both inside a mass as you go towards the centre and inside a charged sphere as you go towards the centre. And you can sketch the graphs for both of these situations. Well done. To ensure you understand what you have learned so far, I would like you to take your learning and adapt it in the form of a cartoon. It doesn't matter if you can't draw. The important thing is that you show you understand what the rules are for gravitational and electric fields in your cartoon. Once you've done this, you should add your learning today to your Venn diagram. This diagram now has information from it at least 4 sessions on it so far, and if my diagram is anything to go by, it's getting a bit messy. So why not start a new one and neatly record all the similarities and differences you have come across so far. We have 1 more session to go in this section before we do a review of all of gravitational and electric fields. So you will find this diagram incredibly useful. Goodbye.